Hi everyone, good evening. Last class, I'm explaining the Matplotlib library, the for users for visualization, and I have some created on plots and also line plot, pie plot like that. Today I'm explaining like a Seaborn library in Python. Uh, Actually, Seaborn is a Python data visualization library based upon the Matplotlib only. It provides a high-level interface for drawing attractive and informative statistical graphs. Seaborn simplifies the processing of creating, usually appealing the plots such as scatter plots, bar plots, and heat maps, while also offering the features for statistical estimation and interface. It, it practically useful for exploring the relationship in datasets and presenting them in a visually appealing way. Uh, and here are some key features and components of this Seaborn is first one is high level interface and integration with the pandas, statistical estimation, flexible plotting, color palettes, face and grids, and themes and styles, and integration with Matplotlib and this thing. Firstly, we have to go like high level interface. Mean Seaborn provides a high level interface to creating attractive statistical graphs. It offers the simpler and more consecutive syntax when compared to the Matplotlib, making it easier to generate the complex visualization with a few lines of code. After that, we have to moving from integration with the pandas. Seaborn seamlessly integrates with pandas data frames, allowing to easily visualize the data stored in data frames. The integration simplifies the process of data manipulation, analysis, and visualization. And we have to move forward for statistical estimation. Seaborn includes the functions for automatically estimating and plotting, estimating and plotting summary of statistics such as means, medians, and confidence interval. These functions make it easy to visualize the relationship and trends in data. And one more thing, the flexible plotting functions. Here the flexible plotting function, Seaborn provides a wide range of plotting functions for creating various types of statistical plots, including like scatter plots, line plots, bar plots, histograms, and Wheelan plots, heat maps, and more. Each plot, each plotting functions offer the customizable options to control the appearance, the style of the plots. And one more thing that color palettes. Seaborn offers the various built-in color palettes. Color palette is nothing but for suppose we have to look like one bar graph. We have separate for male and female. Male having one color and female having one color. The color patterns in this actually the palette means they have more of the colors gradients is there. We have to choose one means we have to choose that colors. And improve readability and visual appeal. This palette include the sequential driving and categorical color schemes allowing to choose the appropriate the palette for your data type and visualization goals. Face grid. Seaborn supports the creation of face and grids which allow to generate multiple plots based on the subsets of the data. Face and grids are practically useful for visualization relationship across difference the categorical variables or subsets of the data. And one more thing, you have themes and styles. Seaborn include the built-in themes and styles that can be used to customize appearance of the plots. Themes theme control the theme control overall the aesthetic of the plots, while styles affect specific elements such as fonts, colors, and grid lines. And one more, the integration with Matplotlib. Although through the Seaborn provides it as one high-level interface for creating plots, it is built on top of the top of Matplotlib and seamlessly integrated with it. This means you can combine Seaborn's advanced statistical visualization capabilities with Matplotlib low level customization options is needed. The overall Seaborn library is a versatile and used for friendly library that simplifies the process of creating the informative and visualization appealing statistical graphics in Python. Whether you are exploring the relationship in your data, analyzing the trends, or presenting the insights to others, Seaborn provides the tools you need to effectively you need to provide visualize your data, and we have to go see seaborn plots are divided into like six plots, and the categorical means whether the 0 or 1, and distribution, relational, and regression matrix, and multiple plot of the grids. Whatever the cat, for suppose here we have to divide into six plots of the seaborn of the plots. Here we have to divide into, again we have categorical plots, we have to divide into seven plots like count plot, bar plot, villain plot, strip plot, box plot, and swarm plot, and factor of the plot. And distribution also divided into four plots: dis plot, joint plot, pair plot, reg plot. Regression is also divided into some plots like simple plot, linear plot with additional parameters, setting the size and color of the plot, and displaying the multiple plot, size and aspect of the ratio of the plots. And again, we have to divide in matrix like heat maps and color cluster maps. Here we have to installing like here we have to install the library from Anaconda. Firstly, I'm installing that library, Seaborn. After that, I'm importing the libraries. After that, I have to read the data. Here the data is like this data is Titanic data set, and we have to like have to some we have to whatever the columns, and we have to check. Here we have to check like data dot head. We have to display the five columns. These are the five columns, and we have to check like data dot tail. D dot tail. We have to display last of the five column the total, and we have to check the shape. Here the 891 of the columns and 12 of the rows, and we have to check whether the data.info, we have to get total information. Here I have to take some categorical of the variables like name and sex. These are the objects, and these are the floating point. These are the integer values, and ticket is an object, and fare is an float, and cabin and MR, the both of the objects is called null value. I mean numerical variables. Categorical, sorry. These are the categorical variables. And firstly, I'm creating some basic plot. Firstly, I remove all outputs. This thing. First of all, firstly, I'm creating a basic bar plot. Here I'm choosing like sex. I mean, sex means whether the gender is male or female. Here we have to take this it's male or female is there, right? This thing. Here I'm choosing the x. Here I'm choosing x equals to of the, I mean, sex of the column. We have to take the data. Data equal to d means we have to plot this thing. Whatever the data, we have to call it in that data. In that data, we have to call it that one column. That column is an x. X means this one, and y means this. For suppose we have to change that, means we have to change the plot also. this thing. So for suppose we have to change the dimension, we have to change the figure also. This thing, this like that. After that, we have to importing like my matplotlib import the figure and sss dot fair. Here the fair is fairing that this one. This much of the column. And this thing we have to display this that. In this that only we have to take visualization insets of the each and every port. For suppose here I'm creating like this is actually we have to display with the three of the column. Here I'm using like x is an one column and hue is an another column and y is also is there. Y is an third dimension of the column. Here we have to take the insets. For suppose there's x column is whether the survive is at 0 or 1. 0 or 1. 0 means survived and 0 means not survived and 1 means survived. For suppose the male is blue color. Mostly of the blue color is total for 400 up means we have to not survive. And whatever the female means almost 90 thing 99 I mean here we have to take the 90% we have to not survive. For suppose here the male survived means 100 and we have to take female is survived with 200 above. These are the insight. We have to deeply analyze of the data. This thing only. For suppose we have to change the color palette also. Here we have to like a blue and orange, right? For suppose here we have to take like a color palette. Here we have to take palette. Palette means of the color. For suppose these are the color gradient. We have to check. We have to change the color means we have to almost all change it. There we have to check what are the colors is there, right? These are all the colors. For suppose we have to choose these ones. This thing, right? We have to change these names. Yeah, it almost all color is changed. After that, we have to take like sns.converts. Sorry, actually the axis survive. This thing. And the face color is 101, line with the edge color, and SNS the color of the palette is gunpowder. Yeah, this thing. For suppose just I'm for suppose here I'm using this thing also same. First of all, I'm calling the data of x column is survived and hue is unset and data equals to I'm calling the whatever the data. After that, I'm choosing one face color. Is the face color means here we have to take a here. These are the parameters. Wait. Dimensional data, index of the columns, data, and these are the inside of the parameter. We have to check it here. Whatever the data. And these are the face color. If the face color is nothing but this of the white color of the code, and we have to check the line of the width. Whatever the line of the width is one, and edge color sns dot palette of gun plot. Whatever the gun plot of the color, this one only. For suppose we have to change the line of the width is 5, we have to change like that. For suppose we have to choose like 10, this thing. That's why I'm choosing one of the width of the lab. After that, I'm explaining like three dimensions is there, right? One is an X, another is one Y, and hue is another of the dimension, that 3D. Whatever the three. Total we have to take like of the three colors. We have to take three columns. One is X column is an sex and Y column is an age and hue is an P class. P class is nothing but this one. For suppose the class is there, right? Passenger of the class. Wait, data, where is the data? Wait. Yeah, this one. Get the data for suppose there are passenger classes. Passenger classes total of the three of the there. For suppose one means first class, second means second class, third means third class of first means first class of the people like AC like that. For suppose the second class means we have to take like sleeper. For suppose third class means we have to choose like general compartment like that. Here we have to deeply analyze of the data. For suppose the male, this one is a male and this one is a female. We have to check the first class. Here the male we have to check the most of the male classes top is 40% and two is known as color, orange color is than 30 of the people and 3 is that 25 of the peoples is 25 peoples of the survived in this area. For suppose in that we have to go like female means we have to take 50 per, like we have to choosing like 35 and 28 and almost all 22. This thing only we have to take. Here we have to take huge order. Huge order is nothing but, for suppose huge order is nothing but a, for suppose we have to take like one, two, three. We have to take like one order is there. First of all, one, two, three, whatever the grade, whatever this bar, this lines is there, right? First of all, I'm choosing random. Default they are having like a sorting orders. For suppose ascending order one, two, three. For suppose we have to change that order means we have to change this thing. For suppose three, two, one. For suppose 3 to 1 we have to change means, for suppose 3 is an blue color and 2 is an, we have to change the bar plots 3 2 1 like that, where the 3 is and this one and this thing. Yeah, here we have to take one capsa. Capsa is nothing but whatever the range we have to spread out that the data. This range is final. For suppose this CI equals to none means the cap size is not, the cap size is omit. Here we have to take color huge order data type and see if the none color is black. Same the thing only, just change the color. After that we have to check the box plot. Here the block spot is, this is a minimum value, this is a maximum value, this is a mean, and this is also a, this is also called as median also. By using box plot we find out the outliers also. These are the outliers of the data. Outliers is nothing but a, outliers is nothing but just randomly closest of the data. Uh, for suppose in mostly affect the outliers are affected to the prediction. For suppose I'm choosing one model, in that model mostly affect on the this outlier. That's why we have to replace that outliers. How I replace them means by using like by using median we have to replace that values. After that I explaining, after that I'm plotting like fair and peakless. I have to check the box plot. This of the insights on. After that, we have to check whether the huge of, and we have to take another one data type. Huge is survived or not. After that, here I am using like true means of the prox marker equals to 0, face color is white, and marker size equals to 5, marker edge of the color is black. Here the essence of dog spot, y equals to fair, x equals to age, and a equals to survival, right? We have to check the, we have to check this of the box plots and mix of the data. This is not right, and this one is, here I'm calculating, right? We have to check the mean value, this one, this of the mean value. We have to, whatever the circle of the white, this one is known as mean value. Here the show of the means equals to true. Here I am displacing of the mean value, this of the mean value. After that we have to check the face color is white, this one, and we have to check the marker size is 5, and this one is known as marker size, and marker edge of the color is black, that's thing. And we have to go like vinyl plot, as a not dot vinyl plot. Here I am choosing like violin plot. Violin plot is nothing but whatever the data we have to spread out, whether the x-axis and y-axis. Where this thing is known as bell curve. Whatever the data, we have to spread of the data. For suppose we have to check whether the range is top and whether the change is low, right? We have to display, we have to, by using while and we have to check whether the kernel of the data. And this thing where we have to check like embarked as s this of this, whether the kernel is low or right, we have to check up that data. After that we have to go like strip plots. Strip plot means whatever the data we have to spread, whether the here the one data point, here the mix of the data points, like that we have to display. Here the split plot line of the length of the width and everything. Yeah, this thing. After that, we have by using currently I'm load one data. The load data is its known as iris data set. After that, I'm checking like here we have to check whether the pattern length by using swarm plot. Here the data punch is 0.5 this thing and this thing. How much of the data we have to spread? We have to visualize the things only. This thing, whatever the data, how much the data is spread to how, just for visualization to statistical analysis and everything. After that, by using cat plot is nothing but like, for suppose by using kind of the bar, by using the kind of equals to bar equals to mean they have to change whatever data we have to take bar plot. For suppose you have to check the kind equals to bar, kind equal to block, whatever the data we have to change to block plot. By using kind equals to strip means whatever the data we have to check the plots and everything, we have to strip off the data. Here I'm choosing like swarm plot. Whatever the including data we have to convert it into swarm plot. Same that of the violent plot also. And these are the some plots like hist plot, KD plot, rug plot. These are some visualization of the plots. After that, mostly of the, I'm not explaining the total of number of the plots because there is a lot of plots is there. That's why I'm not telling. Just these things only we have to useful for things. And I'm explaining like some basics for machine learning. Today I'm starting with machine learning. Wait. Yeah. Wait. Yeah, now explaining the machine learning algorithm, basic concept for supervised and machine learning, unsupervised. Now explaining like supervised and unsupervised machine learning. This fields of the machine learning contains of massive set of the algorithm that can be used for understanding of the data. This algorithm can be classified into two categories. One is supervised machine learning, another one is unsupervised machine learning. First of all, we have to go supervised machine learning means involves the building a model to estimate or predict an output of based on one or more inputs. Unsupervised means involving find out the structure and relationship from input. There is no supervising output. For suppose the supervised machine learning, we have to take one predicted column, another one is an another some basics of some like two or three, and most of the 20 of the independent columns. For suppose the unsupervised, we have to take group of the data. And so this thing in that supervised machine learning means the whatever the supervised machine learning can be used as one or more exploratory variables like x1 x2 and x. These are the some features of there, and is the response variable is y. Whatever the response variable is nothing but a predicted column dependent variable, and you would like to find out some function that describe the relationship between the exploratory of the variables and responsible variable is whatever the function equals to y equal to mx plus c. Y equal to mx plus c means we have to take one straight line, whether the f whether the y equal to mx plus c, whether the m represents the systematic information that x provides the about y, and where e is an random error independent of x with the mean of the zero. And then supervised machine learning means exploratory way of the variable and response of the variable. Wait, I can share my PDF. Yeah, these are the some basic concepts I am explaining like unsupervised machine learning and supervised machine learning. What here equal to y equal to fmx plus c means m is known as slope and x is an variable and e is an coefficient of the variable. For suppose the whatever the supervised machine learning, the exploratory variables means x1 x2 and x. So these are some variables. These are the exploratory variable and y is known as predicted variable. In someone using like independent variables are x1 x2 and x3, and dependent variables are y. And there are two types of the supervised whatever for suppose you have to take supervised machine learning. In that supervised machine learning you have to take two types. One is an regression, another is an classification. Whatever the regression means, the output variable is continuous. Whatever the regression means, the output of the variable you have to take the continuous values like age and height time. We have to take every day, we have to increase that, right? For suppose we have to take classification means whether the output variable is categorical means, for suppose categorical means categorical data. In that categorical data, whether the male or female means 0 or 1. For suppose we have to take whatever the male and female, we have to take 0 and 1 like movie rating, whether they pass or fail, and begin and end. These things only we have to choosing for classification. These are the two main reasons for these are the two main reasons that we use like machine learning algorithm. After that we have to go prediction. For suppose here the prediction means whatever the data, or for suppose we had to get some one data set. In that data set we have to take one predicted variable. That predicted variable is known as what that dependent variable is known as independent predicted the column. We often like set of variables, and this are the some theory, and we have to take inference. We have many instead of accounting this of the variables of the, yeah, whatever the data. For suppose x1 and x2 and x3, these are the columns is there, right? Whatever this column, these columns is mainly affected to the predicted column. For suppose we have to change that x1 and x2 columns is changes the values, means we have to more effect on the predicted that column. That's it. And we have to take like linear regression, means we have to take like a logistic regression, linear discriminant analysis, gradient analysis, and decision trees, naive bias, and support vector. These are the some algorithm. So for suppose we have to go like unsupervised machine learning, means here the unsupervised machine learning is nothing but a group of data. Here we have to take only variables only. For suppose only exploratory, only independent variables. For suppose we have to take the dependent columns, we have to based upon the future column, we have to take the dependent column. We have to predict the future. I have to predict the dependent column. And supervised learning we have to use like these are the variables and this are the thing, and these are the main two reasons for algorithms. We have to take clustering of the data. Clustering of the data is nothing but like grouping of the whatever the data. For suppose grouping of the data, so for suppose we have to choose like movie rating is there, right? 0 to 5. Wow, 0 to 5, someone using 1, someone using 2, and someone using 3. These things we have to choose for unsupervised machine learning. In that unsupervised machine learning, we have to take some algorithms is there, right? Whatever the algorithm, this one, principal component analysis. Principal components analysis is nothing but, for suppose we have to change like 20 of the columns is converted into 11 of the column. For suppose we have to check k-means of the clustering. For suppose in that algorithm we have to choose a k-means of the algorithm, means for suppose we have to check the whether the distance by using like a Euclid distance. In that Euclid distance, for suppose we have to check one, we have to check the near of the data pair, we have to pick up that one is known as one group of the data. And same we have to follow as k methods also, and directly clustering also, and appearance of the algorithms also. These are the supervised and machine learning. Some these are some description whatever the variables and of the, and whatever the machine learning algorithm, we have to check like two types, supervised and machine learning. In that supervised and machine learning we have to take regression and classification, and supervised machine learning is used for clustering and association. And we have to go like this one. What first of all we have to check the whether the regression and classification. Yeah, this one regression is nothing but to predict continuous output. For suppose the decrease is very far and mid far and mid, we have to increase the rate, right? This thing. And this classification, whether the Fahrenheit meter means whether the cold or right, we have to predict that like that. And regression problems in machine learning. For suppose we have to take one data set. In that data set, for suppose, wait, I have a call. Yeah, I sorry for the disturbance. And regression problems in machine learning. Regression means we have to predict the price like that. For suppose, in one mobile shop person, we have to come up with if we have to come up with one data set. In that data set we have to, for suppose we have to set more number of the mobile, which one choose for students and everything. For that, this is a problem statement, we have to predict the price and everything. And this is known as some of the evaluation models is and cost function. Cost function is nothing but like we have to check the mean square error, root mean square error, and mean absolute error. For suppose we have to check the mean square error mean, these are the formula sigma and y minus y cap whole square. These are the root mean square, the square root of the root of the mean square, and absolute error means y and y cap. And y is nothing but a predicted value, and y cap is nothing but actual value, and is a total number of the samples, and this is the absolute value of the model. An example for regression. Regression problem predicting like house price, mobile price. These are the some problems are there, and someone using like speed of the predict like that. And popular algorithm used for inline linear regression, support vector, machine and regression mean decision tree and random forest. And classification in machine learning. Classification in machine learning means whether you have to predict for suppose mostly you have facing like a mail issue, right? For suppose in that mail spam and ham is there, right? For suppose whatever the mail of for WhatsApp, for suppose we have to check whether the condition, for suppose some we have to divide with the spam and ham mails, well whether you check it the whether check up the mails, we have to check up the mail whether the spam is there, right? Whether the spam is means not much usable for that for that mail. That's why we have to choose like spam, and we have to choose like uh, ham mail. That's thing only they explain. And this thing and some of the basic function. Here the cost function is, here the cost function like accuracy. Accuracy is nothing but we have to check the total number of the combination divided by total number of the product. And confusion matrix. Confusion matrix have to explain another way. And FN score and precision, these are the some evaluation of the matrices. And this thing like some algorithm for classification table and regression and classification. A regression model seeks to the predict the continuous contour. This thing we have to study that. That's it. And then tomorrow explaining one regression algorithm, like linear regression algorithm. I have to detail to explain, and after that we have to go like I have to explain like coding also tomorrow. Yeah, that's it.
मंडी करनी चली आप जिस नहीं दे रहे हैं कृपया कुछ समय पश्चात करें The person you're calling is not answering.